Okay, let's dive into this explainer. Today we're looking at a journey that literally shatters everything we think we know about rigid, traditional education. I mean, we usually picture engineering as this world of cold, hard data, right? Strict mathematics, precise measurements, absolute rules. But what happens when you introduce vibrant, digital creativity into that highly structured environment? Well, today, we are going to explore the story of one educator who took a traditional engineering classroom and turned it into a dynamic, creative powerhouse, completely changing how his students interact with complex data.
The stakes for everything we are about to discuss can really be summed up in one powerful quote. Future-ready engineers must be creative communicators. That right there is the core philosophy of Mohammad Khairul Azam, and honestly, it's the realization that changed absolutely everything for his teaching approach. He recognized that, in today's world, it is simply no longer enough to just know the math. If you can't communicate your brilliant ideas to the rest of the world, your solutions, they just stay locked on a piece of paper. This is all about taking abstract data and turning it into genuine human connection.
Section 1. Engineering meets digital creativity, the intersecting worlds.
So to really understand this shift, we got to look at the architect behind it. Meet Mohammad Khairul Azam. He is an engineering lecturer over at College Metro Kalasi Kajuratarang Kada, or KMKK for short. Now, coming from a very strict engineering background himself, he spent years operating entirely within the boundaries of formulas and highly technical drawings. But his true passion, it lies exactly at this intersection. That precise point where strict technical precision meets expressive digital creativity. He firmly believes modern students shouldn't just be solving equations in a vacuum.
Moving on to Section 2. Bridging the communication gap, the problem with pure data.
Traditionally, engineering education looks, well, it's heavily weighted towards strict mathematical formulas and standard drawings. It's functional, sure, but it's very isolated. But the modern necessity demands more from us. We actually have to visualize abstract data so the real world can understand it. Azam noticed a massive gap between these two necessities in his daily teaching. The reality of his classroom was honestly kind of frustrating. His students were incredibly bright. Like, they could solve equations that would make most of our heads spin, but they lacked the visual storytelling skills to share those abstract ideas effectively. They possessed brilliant technical ideas, but because the instruction relied so heavily on standard formulas, these students actively struggled to communicate their concepts visually. The bridge between the laboratory and the real world was just missing. Section 3. Designing Smart Materials. The Adobe Express Breakthrough.
Now, what's really interesting about this slide is Azam's innovative solution to that exact problem. To build that bridge, he initiated a massive shift in his curriculum. He challenged his students to completely ditch those traditional text-heavy essays that, frankly, often just lead to passive learning. Instead, they transitioned to creating dynamic, highly professional digital infographics using Adobe Express. It's a real game changer. Suddenly, an assignment wasn't just some document handed to a teacher, it was a piece of visual communication designed for a real audience.
So, here's how that student journey actually plays out during the Smart Materials project. Step 1, they start where they always do, as passive learners just absorbing technical data. But step 2 is where the magic happens. They have to synthesize incredibly complex concepts, like, say, the mechanics of shape memory alloys, and map them out visually. Finally, in step 3, they emerge as active digital creators. They're literally turning dense data into an engaging story that anyone can grasp.
Section 4. 3 Pillars of Creativity. The Educator Framework.
Azam formalized his whole approach by getting his Adobe Creative Educator, or ACE, Level 2 certification. And from that course, he extracted 3 core takeaways that essentially became the new engineering laws for his modern STEM classroom. We're talking about creative confidence, visual literacy, and intentional design. Let's break down exactly how he applies each of these to highly analytical students.
The first pillar is creative confidence. Now, design can feel terrifyingly subjective to an engineer. We've all seen that stereotype, right? An analytical mind just totally freezing up when faced with a blank canvas. Well, Azam defines creative confidence as removing that paralyzing fear of bad design by shifting the focus entirely to the process of expressing their technical ideas creatively. It liberates them to take risks without stressing over making artistic mistakes. The second pillar is visual literacy. This is exactly where the technical structure meets the canvas. Azam teaches his students how to leverage visual hierarchy, color theory, and layout strategies to take dense, intimidating engineering diagrams and make them highly readable and impactful. For instance, he encourages structured, professional aesthetic choices, like using a really clean industrial gray and navy blue color palette. This way, the design feels modern and engineering appropriate, but it's super visually digestible.
So the crucial point is intentional design, our third and final pillar. This means ensuring that absolutely every single design choice in a presentation, every line, every color, every graphic, serves a clear, deliberate purpose to simplify complex data. Actually, think about it like this. If it doesn't help explain the engineering concept, it just doesn't belong on the page. This appeals perfectly to the engineering mindset. Design isn't decoration, you know. It is functional communication.
Section 5. Mapping the future. Engineering, what's next?
Having totally nailed this framework with the Smart Materials project, Azam's specific, forward-looking goal is actively integrating graphic organizer templates directly from the Adobe Education Exchange into his daily instruction. He recognizes that, hey, even boundless creativity still needs a scaffold, right? Especially for complex technical problem solving. By using these ready-made templates, he instantly provides that structure for his students.
And this brilliantly illustrates how the workflow actually plays out. You've got students running active brainstorming sessions, they are visually mapping out their rigorous engineering processes, and the final result is structured, creative problem solving. It honors the step-by-step engineering mindset while actively fostering out-of-the-box creativity. Which brings us to the ultimate takeaway from Mohd Carol Azam's incredible journey. It's a challenge, not just for engineering students, but for anyone working in a highly technical or data-driven field. Formulas, data, and code, they will always be necessary to solve the problem. But if you want to make an impact, if you truly want to connect with the real world, how will you engineer the story? Take Azam's framework, embrace that creative confidence, and start designing your own solutions. Thanks so much for joining me on this explainer, and I'll catch you next time.